Right, this is Unit 5, Lesson 3, Graphing Radical Functions. So my lesson essential question is, how can you use what you know about transformations of functions to graph radical functions? At the end of this lesson, you'll be able to graph and transform radical functions. Example 1, graph square root and cube root functions. Graph the following functions. What are the domain and range of the function? Is the function increasing or decreasing? So I have f of x equals the square root of 3x. So I make a table of values and graph. For ease, choose x values that make the radicand a perfect square. So 0, 3, 12, 27. Right, so they make perfect squares. Makes your life a little bit easier. Radical functions do not have a horizontal asymptote. They grow without limit. The radicand of the square root function can only be positive numbers or 0. So the domain is x is greater than or equal to 0. The solution to a square root function always returns a positive value or 0. So the range is y is greater than or equal to 0. As x increases, y increases, so the function is increasing. I want to graph g of x equals the cube root of 2x. So I make a table of graphs, values and graphs. There are no restrictions on a radicand of a cube root function, so the domain and range of the functions is all real numbers. The function is increasing over the entire domain. So for a square root, only positives. For cube roots, you can have positives and negatives. All right, so let's try it. Graph the following function. What are the domain and range of the function? Is the function increasing or decreasing? So I have f of x equals the square root of x minus 5. So the first thing that I want to note is that it is a square root, so it has to be positive numbers. Okay, so my domain and range are going to be positive numbers. So my domain is x is greater than or equal to 5. And my range is going to be y is greater than or equal to 0. And it is increasing.
Miss Brittany is Julie also in the school. Would you please contact the office? Miss Brittany, please contact the office.
Okay, so I'm going to go ahead and pick a couple values for this. I want to pick values that make this a perfect square. So let's see, 0. So I could do 5. Should make this 0. Okay, 5 minus 5 is 0. Square root of 0 is 0. Let's see, the next perfect square would be 9. 9 would work. So 9 is 4, which is 2. So 9 minus 5 is 4. Square root of 4 is 2. Let's see. 3 doesn't work. 5 we already did. 6 is 1. 6, which is 1. 7 would give me 2. 8 gives me 3. 9 gives me 4. 10 gives me 5. 11 gives me 6. 12 is 7. 13 is 8. 14 is 9. 14. Okay, that's probably enough. So I'm going to start with at 5, x is 0, so there's a point here. At 6, it's 1. At 9, it's 2. So my graph looks something like that. So I want to graph the function. I have a cube root of x plus 1, so I know that the domain is all real numbers. The range is all real numbers, and it's also increasing. So I can go ahead and try a couple of numbers. in here. Let's go, again, I want to pick numbers that are easy. Let's see, cube root. So I could do -1, which would give me 0. Cube root of 1 is 1. Let's see, 7 gives me 2. 7 plus 1 is 8. Cube root of 8 is 2. Let's see, if I do negative, I'm not going to have enough room for those. Okay, so let's see, -1 at x is -1, y is 0. Okay. At 0, it's 1. What about, see, -2? Oh, -2 would work. So -2 gets me -2 plus 1 is -1. -1 cubed is -1. So -2, -1 right here. So it's going to look something like this. It has that motion. It goes through those 3 points, and then it just kind of keeps going. All right, so concept, radical function. A radical function is a function of the form f of x equals a to the nth root k x minus h plus k, where a determines a vertical stretch or compression, h determines a horizontal translation, and k determines a vertical translation. So very similar to what we did last unit. Example 2, graph a transformation of a radical function. I want to graph g of x equals 2 square root x plus 3 plus 5. What transformations map the graph of f of x equals the square root of x to the graph of g? How do the domain and range of g differ from those of f? So looking at this, we know that this is either going to be a stretch or compression. This is going to be a horizontal, and this would be vertical transformation. So identify the parameters of g of x. A equals 2, so the function is stretched vertically by a factor of 2. H equals -3, so the graph is translated 3 units. And k equals 5, so the graph is translated up 5 units. I graph the parent function. Okay, so here's my graph. Vertical stretch, the graph of f is stretched vertically by a factor of 2. So each y value is twice as far from the x-axis. The stretched graph is then translated 3 units left and 5 units up to show the graph of g. The domain of f is x is greater than or equal to 0, while the domain of g is x is greater than or equal to -3, because it moved to -3. The range of f is y is greater than or equal to 0, while the range of g is y is greater than or equal to 5. So again, it's up. Okay. So this, if you set this equal to 0, what's underneath, that will give you your domain, and this is usually your range. All right, so let's try it. I want to graph g of x equals 1/2 square root x minus 1 minus 3. What transformations of the graph of f of x equals the square root of x produce the graph of g? What is the effect of the transformations on the domain and range of g? Drag the points to transform the graph of f into the graph of g. So the 1/2 tells me that I'm compressing. So compressed vertically by a factor of 1/2. Okay. So this is 2 points. So now it's become 1 point. Okay. And then it's going to have a shift translated 1 unit to the right and 3 units down. Okay, so I go 1 to the right, 1, 2, 3 units down. Okay. So looking at this, my domain is x greater than or equal to 1. So again, if I set x minus 1 equal to 0, that's x equals 1. So x greater than or equal to 1. My range has gone down, so y is greater than or equal to 3. All right, example 3, rewrite radical functions to identify transformations. How can you rewrite the following radical functions to identify transformations from the parent graph of f of x equals the square root of x? So I want g of x equals the square root of 9x. Use the properties of radicals to rewrite the function and identify a vertical change. G of x equals the square root of 9x. Well, the square root of 9x can be rewritten as the square root of 9 times the square root of x. We know the square root of 9 is a perfect square, which equals 3. So 3 square root of x. So a equals 3, so the graph is stretched vertically by a factor of 3 from the parent graph. Both h and k are 0, so there is no translation of the graph. All right, how can I rewrite the following radical function to identify its transformation from the parent graph of f of x equals the square root of x? So I have h of x equals the square root of 4x plus 16. So I rewrite the function in the form h of x equals a square root k, or x minus h plus k. H of x equals the square root of 4x plus 16 plus 7. Okay. So I factor the radicand, so what's underneath the square root. So I can factor out 4, so 4 times x plus 4. So I have the square root of 4 times the square root of x plus 4 plus 7. Well, the square root of 4 is 2. So I have 2 square root of x plus 4 plus 7. So the graph is stretched vertically by a factor of 2. So each of these points, so 4 becomes, or 2, so it's up to 2, it's doubled, becomes 4, doubled, okay? So the graph of h is stretched vertically by a factor of 2, followed by a transformation of 4 units to the left and 7 units up. All right, so let's try it. What transformations of the parent graph of f of x equals the square root of x produce the following graphs? M of x equals the square root of 7x minus 3.5 minus 10. Okay. So M of x is a vertical stretch. So I can factor out 7, so x minus half minus 10. So this is the square root of 7 times the square root of x minus 1/2 minus 10. So it's stretched vertically by a factor of the square root of 7 as a vertical, as a shift down of 10 units and a shift to the right of 1/2 units. Okay. 1/2 unit to the right and 10 units down. J of x equals -2 times the square root 12x plus 4. So again, I can rewrite this. I have -2 square root 12x plus 4. Well, this can be rewritten as 4 times 3x plus 4. This is -2 times 2 times the square root of 3x plus 4. Okay. So this is -4 square root 3x plus 4. I still want to make sure the x is by itself. So this is -4 square root 3 times the square root of x plus 4. So looking at this, I have a reflection across the x-axis because this is negative. Okay. It's compressed by a factor of 4 square root of 3 and is shifted 4 units up. All right, example 4, write an equation of a transformation. What radical function is represented in the graph? So, compare the graph to the parent function, f of x equals the cube root of x, because I have this type of function that is a cube root. Okay? So step 1, check to see if any vertical or horizontal translations have been performed. Since f of negative x equals negative f of x, you know that the function is odd. Like the graph of the parent function, the graph of this function is symmetric about the origin, so no translation has been performed. Check for a vertical or horizontal stretch. The function has either been vertically stretched by a factor of 2 or horizontally compressed by a factor of 8. Either transformation maps the initial graph to the same resulting graph. 3, identify the transformation. The function g can be written as g of x equals 2 cube root of x, or g of x equals the cube of 8x. All right, so let's try it. What radical function is represented in each graph below? Okay, so this is a square root function. Okay, so I know it has to be a square root. It's moved 5 units down and 4 units to the left. Okay. And it doesn't appear to have any vertical stretches. So I have g of x equals the square root of x plus 5 minus 4. So remember, I moved 5 to the left, 4 down. If I substitute in one of these values, I should get my y value. So if I substitute in my x value of -1, -1 plus 5 is 4, square root of 4 is 2, minus 4 is -2. So there's no vertical or horizontal stretch here. All right, b is a cube root. You can see by how it moves, okay? So it's moved from 0 to -2. So that means there's been a, it shifted down 2 units. Okay. And I have, so let's see, g of x equals the cube root of so I know it's moved down 2. I have x here right now. So I can substitute something in to see if it works. Let's do x is 2. I should get y is 0. Well, 2 cubed, we don't, well, 2 cube root of 2, we don't know, okay? So cube root of 2 minus 2 probably doesn't give me 0. But the cube root of 8 would. So what times 2 would give me 8? 4 gives me 8. 4 times 2 is 8. 8. The cube root of 8 is 2. 2 minus 2 does give me 0. So sometimes it's guess and check to actually figure out what goes under the radical. All right, example 5, interpret a radical function model. Looking out to the sea, the visibility in miles from a certain spot on a cliff can be calculated using the function d of x equals the square root of 1.5x, where x is the height in feet above sea level. Sasha walks through elevations ranging from 5 feet to 40 feet above sea level. What are the minimum and maximum distances that she can see? So there's a picture. So the first thing I want to do is graph the function over the given domain. Okay, so they told me 5 to 40. That's my domain, so 5 to 40. So I graph, just substituting in points. Step 2, look for the minimum and maximum points on the graph. Notice they are the endpoints of the function of the graph along the given domain. Find the value of the function at the minimum and maximum value of the domain to determine the minimum and maximum values that Sasha can see. So for 5, 1.5 times 5, square root of that is approximately 2.74. And for 40, 1.5 times 40 is approximately 7.75. So the minimum and maximum distances that Sasha can see are approximately 2.74 miles and 7.75 miles. All right, so let's try it. Looking out to the sea, the visibility of miles from a certain spot on a cliff can be calculated using the function d of x equals the square root of 1.5x, where x is the height in feet above sea level. Suppose Sasha's brother walks through elevations ranging from 8 to 48 feet. What are the minimum and maximum distances that he can see? So we know that my range is from 8 to 48, so I'm going to substitute those values in. So d of 8 equals the square root of 1.5 times 8, which is approximately 3.46 miles. And then d of 48 equals square root of 1.5 times 48, which is approximately 8.49 miles. All right, so concept summary. Use transformations to graph radical functions. So in algebra, understand how the values of a radical function transform the graph of a parent function. So f of x equals a to the nth root x minus h plus k, where a determines a vertical stretch or compression, h determines a horizontal translation, and k determines a vertical translation. So in graphs, understanding the relationship between the graph of the parent function and the graph of the radical function. So f of x equals the square root of x is the parent square root function. If I graph g of x equals 2 square root of x plus 1 minus 3 is the result of a vertical stretch of 2. So I do that first. And then a translation 1 unit to the left and 3 units down. F of x equals the cube root of x is the parent cube root function, so the blue one. Okay. I'm graphing h of x equals 1/3 cube root of x minus 2 plus 3. I have a vertical compression by a factor of 3. Everything gets smaller. Okay, and then a translation 2 units to the right. So this point right here goes to the right. And then up 3 units. And that is the end of Unit 5, Lesson 3.